Thank you, Katie, for the introduction, and thanks to everyone for joining today's webinar. Today, I'm going to review 5 key considerations for selecting an EV charger, which includes AC versus DC, connector types, enhanced features to consider, EV charger location, and funding options. Let's start by looking at AC versus DC. The debate between AC and DC power is a central aspect of electrification efforts. AC is favored for its efficient long-distance transmission, making it ideal for power grids. On the other hand, DC has advantages in specific applications like battery storage and electric vehicle charging. Balancing the strengths of both AC and DC technologies is essential for achieving comprehensive electrification across various sectors. According to the Department of Energy, there are over 175,000 charging ports in the US. 75% are AC and 25% are DC. What does this mean exactly? Let's begin with a brief overview. Alternating current, or AC, is characterized by its periodic reversal of direction, flowing first in one direction and then the other. On the other hand, direct current, or DC, maintains a constant flow in a single direction. The power that comes from the grid is always AC. However, batteries like those in electric vehicles can only store power as DC. The difference between AC charging and DC charging is the location where the grid power gets converted, inside or outside the car. Level 2, or AC charging, involves a converter built into the car known as the onboard charger, which converts AC power from the chargers into DC to charge the battery. AC charging is the slow and steady approach, great for overnight charging at home or at work. Level 3, or DC charging, however, incorporates a converter inside the charger itself. With DC chargers, power is fed directly to the car's battery without the need for the onboard charger. So DC charging is the fast lane, perfect for topping up quickly when you're on the road. AC and DC chargers both have their advantages, and the choice between them depends on various factors, including charging speed needed, infrastructure integration, future-proofing, and costs. So in summary, AC charging is often more suitable for residential and slower charging needs, offering cost effectiveness, while DC charging excels in providing rapid charging capabilities for long distance travel and high demand scenarios. Let's move on to connector types. Standardizing connectors in the US has been a hot topic over the last 2 years. As EVs gain popularity, understanding the various charging connectors becomes essential. First is the J1772 connector, which is a staple for level 2 charging in North America. It's known for reliability and versatility. It's the go-to choice for many EV owners. Next, let's talk about CCS1. Mostly used in North America, it combines the benefits of the traditional J1772 connector with 2 additional DC pins, enabling faster charging for compatible vehicles. Now let's look across the pond to the CCS2. This is the European counterpart of CCS1. It's designed to accommodate the higher power levels required by European EVs, making it a standard choice across the continent. Next is CHAdeMO, a connector developed by Japanese automakers. Although not as widespread in Europe and North America, it does maintain popularity in Asia, providing fast charging capabilities for compatible vehicles. And last, we have the NACS connector, which has been used by Tesla vehicles in North America, and it's known for simplicity and reliability. This connector increased in popularity when Tesla released the model to open source in late 2022 and is being standardized as the J3400 connector. Each of these connectors contributes to the diversity and accessibility of EV charging infrastructure, accommodating different types of vehicles and charging needs across regions. So whether you're driving across city streets or heading on a long distance journey, understanding these different connectors ensures a seamless charging experience for all EV drivers. Now, let's look at key enhancements you should consider when purchasing an EV charger. Let's first understand your unique requirements. Are you looking for a residential charger, a solution for your workplace, or perhaps a public charging station? There are important enhancements you need to maximize the utility and convenience of your EV charger. For example, cable management. Imagine the convenience of a charger with a cable management system that keeps cables tidy and prevents tripping hazards. It's not just about aesthetics, it's about safety and ease of use. Back-end software needs. EV charging management software allows you to monitor usage, manage billing, and even schedule maintenance remotely. It's the brains behind your charger. Here are a few examples of EV charging management software. Payment systems. Payment options are crucial for public charging stations, whether it's RFID cards, mobile apps, or credit card readers. Providing multiple payment methods ensures accessibility for all users. Branding and customization. Your EV charger is not just a piece of equipment, it represents your brand. Customizing the design and interface helps create a cohesive brand experience for users. Screen sizing. Screen sizes and functionality are often overlooked but can greatly enhance the user experience. A larger screen allows for clear instructions, real-time charging status updates, and even promotional messaging. By considering these essential enhancements, cable retraction, back-end software needs, payment options, screen sizes, and functionality and branding, you can ensure that your EV charger not only meets but exceeds your expectations. The strategic placement of EV chargers can significantly enhance accessibility and efficiency. Let's look at some key factors to consider when determining the optimal location for charging stations. As EVs become more and more popular, ensuring convenient access to charging is crucial. Let's begin by exploring some important questions to consider when determining the placement of EV chargers. First off, how much physical space is available? This question addresses the availability of physical space, whether installing chargers in a parking lot, garage, or other area. It's important to assess the space requirements for both the chargers themselves and any associated infrastructure, such as electrical panels and conduit. Consider factors like the number of charging stations you plan to install and the layout of the space. Adequate spacing between chargers is essential to accommodate multiple vehicles simultaneously and ensure ease of use. Next question is your charger for the public? So consider the intended users of your EV chargers. Are they primarily for public use, such as visitors, customers, or residents in a multi-unit building? If so, accessibility and visibility are key factors in determining the best location. Public chargers should be conveniently located near high traffic areas, be clearly marked, and easily accessible to all users. Some factors to consider include the proximity to entrances, visibility from main roads, and availability of amenities like lighting and signage. Will this be behind the fence? Another consideration is whether the chargers will be located behind the fence or within a restricted access area. This is most often relevant for chargers installed at workplaces, multi-unit dwellings, or other private properties. If the chargers are intended for employees or residents only, locating them behind a secure access point may be appropriate. However, ensure that the area remains easily accessible to those authorized users, and consider measures such as keycard or app-based authentication. Is this an employee building benefit? Building on the previous point, let's look at whether the chargers are part of an employee building benefit program. Offering EV charging as an employee perk can be a powerful incentive for recruitment and retention, but it's essential to consider logistical implications. In addition to convenient access for employees, factors such as parking availability, scheduling considerations, and integration with other workplace amenities should be considered when determining charger locations. Are you located on an AFC? Consider whether your location falls within an alternate fuel corridor. AFCs are designated routes where alternate fueling stations, including EV chargers, are strategically located to support long-distance travel. If your site is located on an AFC, positioning your chargers in a visible and easily accessible location can attract EV drivers traveling along that corridor. Consider signage indicating the presence of EV charging facilities and amenities to enhance the overall experience for travels. In addition, being located on an AFC may qualify you for funding. Funding is key to deploying more EV chargers and pushing the switch to electric vehicles. The fact that around 80% of the country has access to rebates, incentives, grants, or tax credits shows the commitment to boosting electric transportation everywhere. Funding is available from different sources, including federal, state, and utility programs. This guarantees that there are multiple ways for stakeholders to get access to financial support for installing EV chargers. Federal programs have the broadest reach and impact, providing incentives to a wide range of individuals, businesses, and organizations across the U.S. These programs address national priorities and issues such as climate change, economic competitiveness, and public health, while playing a central role in driving progress and reducing barriers to EV adoption. The bipartisan infrastructure law signed in late 2021 represents a significant investment in the future of EVs and the infrastructure necessary for their widespread adoption. This law allocates $7.5 billion to build a national network of EV charging stations along highway corridors and within communities over the next 5 years. The EV infrastructure program has several key goals, including establishing a nationwide network of 500,000 EV chargers along 75,000 miles of U.S. highways by 2030. This aims to address range anxiety and contribute to the broader goal of achieving net zero emissions by 2050. $5 billion of the funding is designated for the NEVI formula program, which empowers states to develop and execute their own EV charging deployment plans. States distribute funding to eligible applicants, fostering collaboration between private and public entities to maximize resources and innovation. The remaining $2.5 billion is allocated to the Charging and Fueling Infrastructure Grant Program, also known as CFI. This is aimed at filling gaps in the national EV charging and alternate fueling networks. This program targets both corridor and community charging projects to ensure equitable access to reliable charging infrastructure, particularly in underserved communities. So, in summary, NEVI focuses on providing EV charging along major highways, while CFI complements NEVI by promoting equitable access to EV charging across communities and highways through grant funding. The NEVI program covers up to 80% of eligible costs related to EV charging infrastructure projects. These costs include charging station equipment, make-ready work, upgrades to existing chargers to meet NEVI requirements, and operations and maintenance expenses. Applicants are responsible for acquiring, installing, owning, operating, and maintaining the EV charging equipment funded through the NEVI program. Applicants are also required to provide a minimum 20% cost match for NEVI funding. This means that they must contribute at least 20% of the total project costs from non-federal sources. The NEVI program includes equity and Justice 40 initiatives aimed at ensuring that at least 40% of NEVI benefits are directed to disadvantaged, low-income, rural, and tribal communities. This prioritization of equity aims to address disparities in access to transportation and EV infrastructure, particularly in underserved areas. The initial funding under this program is directed toward the build-out of state AFCs, laying the foundation for a comprehensive national EV charging network. Once the national network of AFCs is fully built out, remaining funding from the NEVI program can be used to support EV charging infrastructure on other public roads and publicly accessible locations. Federal regulations have set minimum standards and requirements to ensure the effectiveness, reliability, and accessibility of EV charging deployed with NEVI funding. Here are some of the key federal requirements. NEVI charging stations should be spaced approximately 50 miles apart along designated corridors and within 1 mile of an approved interstate, exit, or highway. This spacing ensures that EV drivers have access to charging at regular intervals and facilitates long-distance travel. Each NEVI-funded site must include charging stations with minimum power capability of 600 kilowatts and 4 150 kilowatt DC charging ports. These specs make sure that the chargers deployed with NEVI funding can deliver high-speed charging to accommodate the needs of EV drivers and support rapid charging technology. Charging stations must maintain an average annual uptime of at least 97%. Additionally, each site must include a 5-year operations and maintenance plan to ensure the continued availability and functionality of the chargers. These requirements help provide reliable and efficient charging services for EV drivers, promoting confidence in the EV charging network. NEVI funding charging sites must provide 24/7 accessible charging to the public. This is to guarantee that EV drivers have access to charging whenever they need it, including during off-peak hours, holidays, and for emergencies. In addition to these federal minimum standards, states have the flexibility to establish their own NEVI requirements to address specific regional needs, priorities, and conditions. Overall, the federal requirements for the NEVI program play an important role in ensuring the effectiveness and reliability, accessibility of EV charging funded through the program. In order to be NEVI compliant, EV chargers must meet several requirements, including meeting Build America, Buy America requirements, which prioritize the use of American-made products and materials in federally funded infrastructure projects. This requirement promotes domestically manufactured equipment and supports the U.S. economy. Also, you need to provide a minimum output of 150 kilowatt per port. This high-powered charging capability enables fast and efficient charging for EVs, reducing charging times and enhancing convenience for EV drivers. Chargers must also include a permanently attached CCS1 connector with options for additional connectors such as NACs to ensure compatibility with a wide range of EVs. NEVI-compliant chargers must also provide secure payment options, including contactless payment. This enables EV drivers to easily access charging services and make payments securely, enhancing the user experience. Chargers must also allow interoperability and conform to Open Charge Point Protocol 2.0.1. This makes sure that there's compatibility and communication between different EV charging networks and systems, enabling seamless integration and operability for EV drivers. In addition, the chargers must be designed to securely switch charging network providers without any change to the hardware, allowing for more flexibility. As previously mentioned, chargers must meet a minimum uptime of 97% to provide reliable and dependable charging services for EV drivers. By following these NEVI compliance requirements, EV chargers deployed through the program can provide high quality, reliable, and interoperable charging services. Another important federal incentive is the federal 30C EV charger tax credit, also known as the Alternate Fuel Infrastructure Tax Credit. It has gone through some changes over the years and most recently renewed after its expiration, with the current law applying to chargers put into service between January 2023 and December 2032. Applicants can receive a tax credit of up to 30% of the total cost or up to $100,000, whichever amount is less, for commercial EV chargers, infrastructure, and installation costs. Businesses, fleet operators, and commercial entities are eligible to receive the tax credit for installing EV charging infrastructure at their facilities. Certain tax-exempt entities such as state, local, tribal, and other qualifying tax-exempt organizations may also qualify. Chargers must be installed in locations meeting specific census tract requirements, such as low-income or non-urban areas. This is to promote installation to areas where access to EV charging may be limited, and this incentive covers around 2/3 of Americans. Commercial and government entities can determine if their installation is in a qualified census tract using Argonne National Laboratory's locator tool. Customers must also follow prevailing wage and apprenticeship guidelines for installation, or this credit will be capped at 6% of the cost. You can claim this credit on your federal tax return using IRS Form 8911 for equipment placed in service during that tax year. The tax credit allows taxpayers to carry an unused portion of the credit back for 1 year or forward for up to 20 years. This means that if a taxpayer cannot use the full amount of the tax credit in the year it's claimed, they can apply the remaining portion to reduce tax liability in future years for up to 20 years after the credit was first claimed. Also, utility companies and state agencies may offer EV charging incentives that can be stacked with the federal tax credit. In addition to federal funding, many states and local governments offer various forms of rebates, grants, and incentive programs to encourage the installation of EV charging stations by substantially reducing the overall cost of installation. EV charging incentives are available at various levels of government, including state, county or regional, and city or municipal levels, targeting different types of users and locations. There are several key aspects to consider when evaluating these incentives. One is the type of charger. Incentives may apply to level 2 or DC chargers, or in some cases, both. Another consideration is the program type. Programs can be competitive, where applicants compete for available funds, or they can be rebate-based, where applicants receive a reimbursement after installation. The availability of funding may be on a first-come, first-served basis until funds are depleted or until a specified date. This means that applicants need to act quickly as soon as the program opens to maximize chances of receiving the incentive. Incentives may target specific user types or locations, such as low-income communities, business fleets, public charging stations, workplaces, multifamily residences, or municipalities. And eligibility criteria may vary based on the intended user or location type. One sample state program is the California Electric Vehicle Infrastructure Project, also known as CAL-E-VIP. The program offers rebates and incentives to support the installation of EV charging stations in publicly accessible locations across the state. Incentives are based on counties and vary slightly, but include both level 2 and DC fast charging projects. So even if your state or local government doesn't offer any incentives, there is a good chance that your utility company will. Utilities are very invested in supporting EV charging infrastructure because it can help manage electricity demand, promote grid stability, and potentially increase electricity sales. So as a result, they may offer a variety of incentives to encourage customers to install EV charging stations. Utility incentives in various forms are available to encourage the installation of chargers and offset the costs associated with purchasing and installing equipment. Many utilities offer rebates and incentives for the purchase or installation of L2 and DC equipment. The rebate amount can vary based on the type of charger, its power level, and location of installation. Like state programs, utilities can set certain eligibility requirements targeting certain users and locations. Additionally, utilities may offer make-ready incentives to cover the costs associated with preparing a site for EV charger installation. This can include upgrades to the utility side infrastructure such as panels, meters, and transformers, and the customer side infrastructure such as wiring and electrical connections. One resource available to identify incentive opportunities is the Joint Office of Energy and Transportation's U-Finder. This is a tool that helps users find available utility rebates, incentives, and programs by searching your state or zip code. Here's a look at some of the available utility programs. One utility that offers some of the best charging incentives is Southern California Edison with their Charge Ready program that offers post-installation rebates, utility and customer side infrastructure upgrades, and incentives for fleet charging. Ameren offers incentives for businesses installing chargers at workplace, multifamily, and public locations with rebates up to $5,000 per L2 port and $20,000 per DC port. Applications for this program are accepted through the end of September or until funds are exhausted. Tucson Electric Power's Smart Charging EV program offers incentives for commercial customers installing L2 or DC charging ports with higher rebates for projects in lower income areas. Rebate funds must be distributed by the end of December 2025. The Joint Utilities of New York is a group of utility companies providing services to the state of New York. Their EV Make Ready program offers incentives for installing L2 or DC chargers. Both public and non-public projects qualify for this program, which includes substantial funding of over $885 million, including $372 million earmarked for disadvantaged communities. Some incentive programs such as SCE, TEP, and Joint Utilities of New York used approved product lists, which require projects to use an approved charger or network to qualify for that incentive. BTC's products are listed on the majority of these lists, and we actively pursue approval on new programs as they become available. Several other utilities offer incentives, and this is just a snapshot. Also, there are opportunities for combining or stacking utility programs with federal and state incentives to help maximize savings. Just be aware of the limits and rules associated with stacking rebates, since some programs have caps on the total rebate amount or specific restrictions on which combinations are permitted. To summarize, today's discussion covered 5 factors to consider when selecting an EV charger. The first is the appropriate charging level to align with your charging needs. Second is choosing the right connector type to ensure compatibility with the vehicle. Third is enhancements like cable management, back-end software, and branding to ensure that your EV charger exceeds your expectations. Determining the best location for your EV charger, and available funding options to help offset costs associated with purchasing and installing EV chargers. Thank you so much for joining today, and we will now move on to the Q&A to address any questions.